Okay, so online people, you should have tried the 12 drill multiple choice. It says chapter 5. It's really our chapter 3 and 4. Try the 12 questions in 16 minutes from our live class here. Show me thumbs up. Was it easy to finish in time? It seems like a few people had to scramble. Maybe not. Maybe about a third of the people say easy, and then two-thirds not quite. Maybe if you check your accuracy. Now, you should be like bursting with joy if you're getting like 100% on these. No, 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 no. That's not even realistic. I myself, like you saw, would race through the test in half the time, double check, and get about 80% right. That's realistic. So your goal is to get to, I'm thinking about 65% for a curve. I know it officially said 70, but I'm reading, I've assessed the honors class already in my Algebra 1 class, and it turns out people are a little more stressed out this year than normal. So probably 65 is fair. 65 is the highest curve that College Board ever uses. So, but I don't have good data for them last time. So let's go over these real quick together. You get the packet, so I have your score, and you can get feedback. But to get 100% on this assignment, you have to show me work and correct these, if any. And if you already did work on the paper and you got them right, you can just check it and say, oh, I'm right. Okay, do you even remember? So I didn't think I had to lecture again. The symbol for displacement is delta x, the change in position. Okay, it boils down to distance with direction. Okay, but did you think about that? So we take a constant speed in a circle back to our place, and you can imagine if you want, we're on like an XY grid here, in XY positions. Okay, that's why we waited a couple weeks to tackle this stuff. Which of the following are true? Is the displacement zero? Is the average speed zero? Well, it's constant speed. I really don't think speed can be zero. Which of the following? Is the acceleration zero? We just did a clumsy proof last week. If you go in a circle, you might have not accomplished anything going right back to your starting point. But the acceleration is definitely not zero. It's v squared over r. Okay, we went on and on about it. So the only one that should be true is actually the displacement is zero. If I go around a circle in an xy grid and I come back, my change in x and my change in y are zero. Okay. Yep. To go in order, we'll skip to 2. So number 1 should be A. Oh dear. Vectors. They will show you vector arrows. Like this is something we kind of refrain from doing in honors physics just because I'm not good at graphics, things like that. But here's V1. It's perfectly horizontal. Here's V2. It's sloping up a little bit. And they tell me that V2 equals V1. Which is the acceleration? Well, okay, the average acceleration is V2 minus V1 over T. Well, yeah, T2 minus T1. Delta V over delta T. Okay, if you didn't know that. Well, okay, so V2 minus V1. So you make a new vector here that's minus V1 vector, and it points back. So, and they're the same length, right? So I could take like a circle and go past there. So we should actually have up and left. It's deceptive that these choices seem to be as long as those. That's wrong. Okay, there's maybe a special case where this vector is actually as long as those, but they don't specify that. Really, these differences, these change in velocities are probably really small, especially if T1 and T2 are close. Any questions? Sneaky, sneaky, but that was in my proof. I don't feel bad. I try to prepare you for everything College Board is going to do. We also have to try to do some fun labs because that's part of AP Physics. You get to design the labs. It'll be really interesting. We'll start designing at least by the end of this week. But that's why we're doing feedback today. If you need me to spend more time on this stuff, then we will. It's a little bit of extra time. But if you're good, then we need to go. Okay, there's really a ton of stuff. I keep learning I should be starting electricity in December. Like I should start E&M before we finish, especially because we don't have a final exam this semester, declared our administrators. So We should do electricity, the beginnings of it. Get ahead. Okay. So look, be carefully. Okay, a rock is thrown, blah, 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 blah. What are we supposed to do? We're supposed to do, what's its acceleration? Oh no. And it doesn't match. College Board doesn't make a mistake. Let's just say which are true. Okay. If acceleration is constant, then it must move in a straight line. Oh no. Definitely not. Because look at this. You can have constant v squared over r acceleration. You go in a circle. Acceleration is 0, then its speed must remain constant. I think yes. Because if acceleration is 0, the velocity must not be changing at all. And if velocity is constant, then the speed must also be constant. Right? I could have, so the inverse is not true. You could have constant speed going around a circle and a constantly changing velocity. But if your velocity is constant because acceleration is 0, it's like necessary but not sufficient the other way. Any questions? Because that's a bit of a smack. Okay. If the speed remains constant, the acceleration must be 0. Oh no. So only 2 is true. And despite the messed up question, they have answer C marked as well for number 3. Okay. Yes, sir. If they said for number 2, no. If acceleration, if it's going around a circle, its velocity must be constantly changing because the direction is always changing to make it around. But you can go in a circle at a constant speed. Like every time if you move a wheel, the wheel's a solid structure. Every point on the wheel has the same speed. And if the wheel turns at the same rate, then a constant speed. That's pretty easy to manage. Okay. So if they change it to velocity, then yes, number 3 would be true. If you said, if an object's velocity remains constant, then its acceleration must be 0. That's right. Because they said speed, which doesn't specify direction. And we have this really common example of going in a circle where velocity is changing but speed is not. They like to ask for that. Okay, very good. Any other questions? We'll go a little faster so people don't fall asleep. Okay, a baseball is thrown straight up. What's the acceleration? It's g downward the whole time. Number 4, C. That they will give you some. Hopefully, by the time we really test for real. If that caught you today, just be grouchy with College Board. Sorry, but they will give you some easy ones. A car starts from rest, accelerates uniformly. Can I zoom in? No. A straight line. How long would it take to cover a distance of 200 meters? Oh, it starts from rest. Okay. Delta x equals 1/2 at squared. Okay, that's my equation number 2. The x equals x0 plus v0t, blah, 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 blah. That's equation 2 where v0 equals 0. And my acceleration was 5. So I have just 200. Actually, I would write 400 because it's easier, equals 5t squared. So t is like the square root of 80, which is about 9. Yeah, they're bad at math. 9 is the square root of 81. But they rounded to 2 sig figs. Oh. So it's probably close enough. Right? Does the square root of 80 rounded to just 2 places? Does it round to 9.0? 8.9? Okay. But they're going to say, so this is a practice, so they didn't put the official directions. The official directions are going to be use g equals 10 and choose the best answer. It doesn't even have to be right. It doesn't even have to be true. It just has to be better than the other 4 choices. Terrible, College Board. Really terrible. Change it to red. Anyway, okay, we're dropped off a cliff. Strikes the ground 30 meters a second. How high is the cliff? Okay. Dropped from rest. It takes 3 seconds. to speed up from 0 to 30, because my acceleration's 10. How far do you fall in 3 seconds? Oh, it's 1/2 gt squared. He's in the same equation again. And t is 3 seconds, so it's 5 times 3 squared is 45. Okay. When things drop from rest, or when they accelerate from rest, 1/2 at squared, 1/2 gt squared, we're going to use that a lot, and we're going to even use that to prove things. Okay, that's why it's like we can't just go back to the equation sheet and hunt for that. That's got to come right out of your memory. So at least it's not a long equation sheet. I strongly suggest you memorize it. Okay, oh no, horizontally from a bridge, how long would it take the stone to strike the water 80 meters below? Oh, well horizontally, okay, so there's a v0x, but that's v0y is still 0. Whoa. So we have 1/2 gt squared again equals 80 meters because the x and y are separate. So 1/2 of g is 5, t squared is 16, so 4 seconds. Okay, here's a soccer ball kicked on the ground at 30 degrees. Oh, did you use the sines and cosines in the front of the equation sheet? If it's 10 here and you're at 30 degrees, then this one's 5 meters per second. And this one's going to be like 8.3, if I'm guessing. Okay, calculate the total flight time. Okay, if you start up at 5, it's going to take half a second to stop. 5 divided by 10 meters per second squared, and another half second to get down. So B. Okay, and now they give an equation for position for number 11. What's the object acceleration at times t? Okay. Well, that's kind of a doozy if you haven't practiced. Okay. Oh, and I chopped off. That goes to number 12, I think. Anyway. I'm not sure how to get acceleration from that. But remember how acceleration, that's a D. Acceleration is the derivative of velocity with respect to time. Aha, so if I knew the velocity, then I could do that. Well, your velocity is just the derivative of x with respect to time. Remember how that's t to the first power, so take away 1 t power. 5 is constant, nothing happens. 7 times t to the 1, that just ends up being plus 7. And then 3t cubed. Okay, I take away 1 power, I multiply by the old power, 6t squared is v. I know that's hard to do if you just learned it a couple weeks ago. Don't worry, it gets really fast. Okay, and then dv dt again, t to the first, so we're dividing by t once, we're taking t away 1 time, and multiply by the old exponent. So that's 8 times t. 7 had t to the 0, so when I do derivative again, it just disappears. So 8 times t equals a, and then 5 times 8. Oh no. Oh, it's not 6. I just did what my silly Algebra 1 students did. I added when I should multiply. Maybe I should forgive them a little. Okay, that's better. Oh, it's kind of nice. Like I realized right away, what I was getting is not one of the choices. College Board almost never does none of these. Maybe 1 or 2 questions out of 35 will actually have a none of the above, and they mean that as a legitimate choice. Okay, it has to be one of theirs. They even said choose the best answer, so one of them has to be closer than the others. I was ready to pick 35 till I caught my mistake. Okay, and the last one, oh, 3, because we have to skip. Okay, horizontally again. Okay, find the total speed when it enters the water 4 seconds later. Oh, okay. After 4 seconds, so v0y equals 0, because it's always thrown horizontally. It's not vertically at all, not up or down. So vy after 4 seconds is minus 40 meters per second down. There's no air resistance. Ignore air resistance. So it's 30, 40. So my final velocity is actually going to be plus 30 minus 40. Okay, Well, that's just a triangle that looks like this. I go over 30 and down 40. It's a right triangle. So my other, it's a 3, 4, 5. My other side is 50. Okay, that's your total speed. Right? It's you find the total velocity and then take its magnitude. Any questions about that? New vector people or people who forgot from honors? Okay. Okay, and which one is true concerning an ideal projectile launched at 45-degree angle? The acceleration points opposite the way up and in the same on the way down? No, because we're launched at an angle, and the total velocity vector is always going to be at some weird angle. Okay, except maybe it's perfectly horizontal only at the top. Okay, the speed at the top is 0. No, it's at a 45-degree angle. Okay, well, we're making progress. I narrowed it down to 3. The object's total speed remains constant. What? No, it's kind of like the vertical component as you launch is going to shrink away to 0 at the top, just like it was fired straight up, and then accelerate again going down. So the total speed can't possibly be 0 or constant. Okay, horizontal speed decreases on the way up and increases on the way down. That's close, but it says horizontal. That means x. Or Vx. No, no, no. Okay, so it better be C because I'm proving them all wrong for now. The vertical speed decreases on the way up. Oh, yeah. It slows down. And momentarily at this top, the vertical speed is acceleration. Yeah. 10 has to be E. 9 was C. Okay. The velocity of an object moving in a straight line is graphed on the previous page. If x equals 3 at t equals 0, okay, so x0 equals 3. And then they want the position. So x equals x0 plus delta x. And delta x is the area under the graph. And we want t equals 0 to t equals 3. Okay, we talked about that. Yes, no. Finding if I want to move back up, like I don't just do my antiderivative and stuff like that, the derivative is the slope on the graph. Well, the antiderivative is the area on the graph. So I can just get my area. Give me a thumbs up if that made sense. Okay. So I'm clumsy. I have to actually look at my graph. We were going from 0 to 3. Double check. I laughed at some honor students who I put 1 to 3, 1 to 4 or something on my test to be mean. It's 0 to 3. Okay, so I go 0 to 3 and then stop. Watch out for the x-axis here. So thank goodness we're ignoring this nonsense. We'd have to subtract that one that goes below the x-axis, like where the velocity is negative, now it moves backwards, right? Okay, so we got 1, 2, 3, 4 full boxes, okay, and each box is 1 by 2, so we're actually just doing 4 times 2. Luckily I had 2 triangles, I count that as 1. So 1, 2, 3, 4. And that's a plus 8 meters displacement. So delta x is plus 8 meters. So 3 plus 8 is 11. Okay.